Welcome everybody. I want to take a little bit of time to go over the questions on your quiz that you had on Friday. So number one says a loaf of bread has a mass of 500 grams and a volume of 2,500 cubic centimeters. The density of the bread is blank. All right, so the first step we should do is identify what information is given to us. So we have 500 grams, 2,500 cubic centimeters. So mass measures grams, so 500 grams is M, and 2,500 cubic centimeters, that's a unit for volume. So that means that I need to figure out density. So if you remember, your equation for density is mass divided by volume. So I just plug in the variables that I know. Since my equation's already arranged to solve for D, I don't have to do anything other than plug in my variables and solve. So mass is 500. The volume is 2,500. And when I type this into the calculator, 500 goes into the calculator first, divided by 2,500, and you end up with a density of 0.2. And these units are grams per cubic centimeter. All right, looking at number 2. Says the density of a substance is 4 grams per cubic centimeter. If a sample of the substance has a volume of 25 cubic centimeters, then the mass is blank. All right, so just like before, let's identify what we are given here. So it says the density of a substance is 4 grams per cubic centimeter. So here is my density. It says the sample has a volume of 25 cubic centimeters. So this is V. And then it says the mass is what? So that means I'm solving for M this time. So same equation, density equals mass divided by volume. Now, the equation is set up to solve for D, but that doesn't mean I can't rearrange my equation to solve for M. If I did want to solve for M, the rearranged equation would look something like this. So if mass is divided by volume, and I want to get mass by itself, I have to move volume to the other side by doing the opposite operation. So I'd multiply this side by V, and multiply this side by V, and on the right, my V's cancel. So that means that on the left, I get volume times density equals mass. So all I'd have to do is multiply my volume and my density. So I'm going to plug it into the equation like we normally do, where, density is 4.0, mass is unknown, volume is 25. All right, so just like we said, you can either multiply 4 times 25, which is essentially what we're going to do by creating a fraction on the left and cross multiplying. So it's 4 times 25 equals 1 times M. You know that 1 times M is M, and 25 times 4 is 100. And my units are grams. Okay. Let's zoom in a little bit on this next question here. Question number 3. It says you have a lead ball with a mass of 420 grams. The density of lead is 10.5 grams per cubic centimeter. The volume of the ball is what? Okay, so we have a lead ball with a mass of 420 grams. So it's telling me the mass, that's M. It says the density of lead is 10.5 grams per cubic centimeter. So this is D. So that means I'm solving for volume, which is V. Okay, so same equation, density equals mass divided by volume. Okay, so I could do this one of two ways. I can plug in the variables that I know and rearrange to solve for V. Because this equation is set up to solve for D, I can also manipulate it ahead of time with just the variables. So if I want to get V by itself, but it's being divided by, or the numerator is M, it's being divided by V, then what I'll end up doing is I'm going to move V to the other side. So that gives me V times D equals M. But if I still want to get D by itself, V by itself, then I have to do the opposite operation to get d to the other side. So when I divide by d on both sides, these d's cancel, and I'm left with v all by itself. And on the other side, I got mass divided by density. All right, so if I can either set up my equation that way or continue setting it up the way that we've practiced. So the density is 10.5, the mass is 420, and the volume is unknown. So like we practiced before, if I've got a fraction on the right, I want to make a fraction on the left, and I'm going to cross multiply. So on one side, you get 10.5 times v. On the other side, you get 420 times 1, which is just 420. So your last step, because you want to get v by itself, is to divide both sides by 10.5. Whatever you do to one side, you must do to the other. And that allows me to isolate for v. And 420 divided by 10.5. 420 goes into the calculator first. 10.5 goes into the calculator second. When I divide those two, I get 40. All right. Next question. Using the image below, we are going to figure out the starting volume. So I just want to know what volume the liquid is starting at. So here you got a koala that's going to be placed into this column of liquid. We don't know what the liquid is. And then it shows you after the fact that koala is in the liquid, and you should notice that the volume has reached a new height. So all that this one is wanting to know is the initial volume. The initial volume. So this is VI. What is the starting volume? So when I look at the column on the left, I see that this water or liquid seems to be at 50 right on the dot. So the starting volume is 50 milliliters. The next question is asking what the new volume is. All right, so we've placed the koala into the liquid. We've dropped it in, and you notice that it has risen. It started at 50, and now the water level went up to 60. So the new volume, also referred to as the final volume, is 60 milliliters. The third question is asking you to figure out the volume of just the koala. Okay, so to figure out the volume of just the koala, you've got to recall your information from questions 4 and 5, where the initial volume, the starting volume was 50, the final volume was 60. So to figure out the volume of the koala, we subtract the two, VF minus VI. In other words, your final volume minus your initial volume gives you the volume of the koala. So the volume of the koala is 10 milliliters. Now that we have our volume of the koala, now we want to know the density of that koala. So it's telling you the mass of the toy koala is 3 grams. The density is what we need to solve for. So we're given mass, we need to solve for density, and you need to recall your information from the previous questions. When we subtracted the final volume and the initial volume, we learned that the volume of the koala was 10 milliliters. The mass is given to me, it's 3 grams. I need to calculate density. So if density is mass divided by volume, then I'm just going to plug in my variables. For mass, I'm plugging in a 3. For volume, I'm plugging in a 10. 3 goes into the calculator first, divided by 10, and you get a density of 0.3 grams per milliliter. Okay. question number 8 is very similar to that with the koala, except it's all in one step. So this question says the mass of the toy diver is 1.2 grams. So it's telling you M. You need to figure out its density. So we're going to practice the same methods that we did with the koala. Find the starting volume. All right, so it looks like my water level is here. Remember, I'm reading at the bottom of the curve, and then I'm looking between 3 and 4. And there are 1, 2, 3, 4, 5 spaces between 3 and 4. So I know that these are counting by 2s. But if this is 3 and 4, that's only a difference of 1. So that means that these increments are 0.2. So that means that, let me mark this. This would be 3.2. This would be 3.4, 3.6, 3.8, 4.0. So it looks like my water level is right about here. I would say the starting volume is 3.4. Now when I look at the final volume, when the diver is in the water, it looks like it's right on the line of 5. Okay, so your starting volume is 3.4. Your final volume is 5. So I need to figure out what the total volume of the diver is. So VF minus VI. So 5 minus 3.4 gives you 1.6. Okay, so the volume is 1.6. Now I can calculate density. If density is mass divided by volume, and my mass is given to me at 1.2 grams, my volume we determined was 1.6 grams per milliliter, then 1.2 divided by 1.6 gives me 0.75. This is grams per milliliter. Remember, 1.2 goes into the calculator first, 1.6 goes into the calculator second. All right, questions 9 and 10 are related to percent error. So number 9 says Josh uses his thermometer and finds the boiling point of ethyl alcohol to be 75 degrees Celsius. He looks in a reference book and finds that the actual boiling point of ethyl alcohol is 80 degrees Celsius. His percent error is what? So your equation says percent error equals accepted value minus experimental value. So you need to remember which is the accepted value and which is the experimental value. So any number that's determined to be true in an experiment is the experimental value. So in this case, Josh is using his thermometer to find the boiling point, and he finds it to be 75 degrees. So that is his experimental value. That is the value that he finds. So the value that you find as a student, or the value that another student finds, is always going to be the experimental value. So I'm going to write that over here. 75. So the actual boiling point, so he looked it up, and he knows that the actual boiling point is 80 degrees. So that's the accepted value. That's the known value. So 80 degrees. So it's 80 minus 75 divided by the accepted value again, which you already determined was 80, and then times 100. So I would type this into the calculator, 80 minus 75 first, and you should get 5, and then 5 divided by 80. Let me write this down here. So 5 divided by 80, and then your last step is to multiply by 100. Multiplying by 100 converts your decimal to a percent. It moves the decimal 2 places to the right. So 5 divided by 80 is 0.0625. But when I multiply it by 100, I move the decimal 2 places to the right, and I get 6.25%. So remember, the closest to 0, the better. So 6.25% is relatively close. He was only off by 5 degrees. So I would say that's a good calculation of is temperature. Let's look at question 10. It says the density of water at 4 degrees Celsius is known to be 1.00 grams per milliliter. Kayla experimentally found the density of water to be 1.075. What is her percent error? Okay, so it's telling you here the density is known to be 1 gram per milliliter. This is the known value. This is the accepted value. So the accepted value is 1.0, or you can add 3 zeros if you like. It says Kayla experimentally found the density of water to be 1.075. So this is what she found. Therefore, this is the experimental value, 1.075. Divided by the actual true value, again, of the density of water is 1, and then multiplied by 100. So 1 divided by 1.075 gives you a negative 0.075 divided by 1.0 and then multiplied by 100 to convert to a percent. So negative 0.075 divided by 1 is negative 0.075, and then times 100 moves my decimal place 2 to the right, and I get a negative 7.5%. So how is it that we can get a negative percent error? Is an error error? Well, yes, in some cases you'll see this calculated as the absolute value. So the person that's wanting this calculation would expect it to be a positive value no matter what. But just know a negative value for percent error only means that your experimental value was higher than your accepted value. Okay? If you subtract a large number from a small number, then you're going to get a negative value. So in this case, our experimental value was the large number. Our accepted value is a smaller number. So when I subtract the two, I get a negative value. If your accepted value is larger than your experimental value, like it was up here in the previous example, 80 is higher than 75, when we subtract the two, we get a positive 5, which will lead to a positive percent error. Question 11. The measurements made to determine the density of a material whose actual density was 1.24. How would these measurements be classified? So I've got 3 trials, trial 1, 2, and 3, and the density of each trial, 1.20, 1.20, 1.22. So the statement says that the actual density of this substance was 1.24. So if you're trying to figure out if these are accurate or precise, you've got to ask yourself this question. In order for it to be accurate, are the trials the same as the actual density? Did any of the trials hit the target of 1.24? So I look at 1.20, 1.20, 1.22. I would say no. So I know that is not accurate. When I look, so if it's not accurate, then it can't be both. Now, it's not accurate, but are all 3 of the values close to each other? So 1.20, 1.20, 1.22, I would say yes, they are very close to each other. So even though they are not accurate, because they are close to each other, I would say these trials are precise. And the last one here. The following measurements were made to find the density of a material whose actual density was 7.92. So it's telling you what the actual density of this substance was. So you've got to compare the data to what it actually was or should be. So I've got trial 1, 7.92, 7.91, and 7.92. Ask yourself, are any of these 3 the same as this? And I would say yes. Trial 1 and trial 2 are definitely the same as 7.92. 7.91 is not, but it's within 100th. It's very close. So I would definitely say that they are accurate. Okay, so if it's accurate, then that gets rid of neither. Now let's see if it's precise. Are all three of these numbers close to each other? And I would say yes, they are all within, they are either the same or within 1/100th of a decimal point, so I would say they are precise as well. So the best answer here would be both.